Okay, so in the last video that we did, we talked about how you could take your alkene and you could react your alkene with water, and you can make an alcohol. But the caveat to that is that you needed some kind of an acid, and so the acid of choice that we utilize is hydronium. So just a very small catalytic amount of this is needed to get the reaction to go. And we said the alkene plus water plus a little bit of acid is going to give us our alcohol. We went through the mechanism and we showed, all of the steps. It turned out to be like 3 steps, and I think 1, 2, 3, 4, 5 arrows or something like that. So now what we're going to do is we're going to change this ever so slightly and just put a little twist on this alcohol formation, and we're going to make some ethers instead of alcohols. So what we're going to do is we're going to start the exact same way. We're going to take our alkene. So this is our alkene, and we're going to still need H3O plus or some kind of acid catalyst. The only difference now is instead of starting off with water to make our alcohol, we actually start off with an alcohol, and we're going to end up making our ether. This is the A plus B equals C part of the reaction. Very simple to see that alkene plus alcohol equals ether. Ether is definitely a different functional group than the alcohol. But what's not really obvious is exactly how all of the bonds are being made, how the bonds are being broken. In the previous video, we showed this oxygen being blue and this hydrogen being purple. I'm going to scroll back up and show you what happened at the end of the day, which is at the end of the day for this previous mechanism that we talked about, we lost this purple hydrogen and we were left with our green hydrogen right there. So what I'm going to do is just take away this purple and we're left with green. So essentially what we have at the end of the day is our blue oxygens are still retained. They haven't been changed at all. This green hydrogen, that's still there. And as soon as we switch this hydrogen to a methyl, we've effectively gone from the alcohol formation to an ether formation. So basically what's going to happen is that this methyl is acting in the same way as this hydrogen. So if we wanted to redo the mechanism for the ether formation, we would have the same first step. We have our acid catalyst, but instead of having water, we have a methyl group that's green, that's just basically replaced an old green hydrogen. So this would be our methyl, and so then the first step is exactly this, or the second step is exactly the same, oxygen attacks. And then for the next step, the only thing that's different between the alcohol formation and the ether formation is then again, we have this green hydrogen replaced with a methyl. And so the third step is exactly the same. We have to lose that purple hydrogen, and we can just use extra water, or in this case, if we wanted to use, an extra bit of alcohol, we could do that. And so then at the end of the day, we've lost that purple hydrogen and we're left with our green methyl. So at the end of the day, we get our ether. And so as you can see, the mechanism is really no different in between the formation of the ether and the formation of the alcohol.